Yes, please check. Am I audible? And the PPT is visible?
Yes, sir, it is visible, sir.
Okay. Thank you. Yeah, now we'll go for determine phase width. There's a phase width that should be a greater than this value, that is a minimum phase width, and whatever the value you choose the phase width, that should be less than the maximum phase width. How do you get this? By taking these two equations, the minimum phase width equation, maximum phase width equation. Now again, what is the value of go for select here? Again, here also we'll go for assume b is equal to 10 times of normal module m suffix n. Next, y is what? Lewis tooth form factor for weaker member. Again, pt, p suffix t stands for transverse circular pitch. Again, transverse circular pitch is what? Normal circular pitch divided by cos beta. Again, as you know, normal circular pitch is 5 into mn, 5 into mn by cos beta. That is, you get equation number 23.213. Next, kv. Kv stands for what? Velocity factor. Right? Kv is the velocity factor that depends upon mean piston velocity. Before that, again, one more terminology is C suffix W. C suffix W stands for wear and lubrication factor. Wear and lubrication factor. How do you get this wear and lubrication factor? By referring the table number 23.47. That is not in regular table number, it is. You go for see the page number 23.86. If this is data is not given in the problem, means what we'll go for assume here? Scant lubrication, but regular and frequent inspection. What is a scant lubrication? Scant lubrication means, okay, the this is a type of the oil or the basin, and a, a cloth or a cotton which is inserted over that, and the another side it is over that the what is the on the gear, measured gear. So drop by drop the lubricant will placed over the machine gear. That is called as scant lubrication. Okay. Then next, what is kV? Velocity factor that depends upon the mean piston velocity. Based on the mean piston velocity, again mean piston velocity is pi dn by 60,000. Again, which is a weaker member that we consider here. Again, d is equal to what? M into module into z divided by cos beta. Okay, that terminology will come here. Based on the mean piston velocity, we'll go for refer these three equations. Now mean piston velocity is less than 12.5 meters per second, then we go for use. This is the formula for kV. If it is more than 12.5 and less than 220 meter per second, the mean piston velocity is more than 12.5 meter per second and less than 20 meter per second, then we go for use this formula. And over the 20 meter per second, then we go for use this formula. Now the slightly equation number changes here for helical gears. Right now, after this, once you substitute, the unknown is a normal module. By comparing equation number 23.87b and 23.286, you go compare it, trial and error method, calculate normal module. Once you calculate normal module, then select the standard normal module by seeing the table number 23.3. Right. Once you get the normal module, what is the next step? We'll go for check for the stresses. What are the stresses induced here? The induced stress should be less than the allowable stress. The same formula we used here. Modified equation of 23.286. What is the induced stress? The induced stress sigma induced is equal to sigma naught into kb induced. Then you go for modify that equation number 23.286. Now we'll get this sigma induced stress. The sigma induced stress should be less than the allowable. So what is the allowable stress is sigma naught into kb allowable. Yes, I'm audible. So I'm getting some poor internet connection. Please
Yeah.
check. Okay, I'm audible,
Yes,
right?
sir.
Yeah. Now, whatever the induced stress should be less than the allowable stress, then design is safe or design is satisfactory. Similarly, go for calculate effective force and bending force. Effective force, as you know that Ft by kV. Bending force, again it is the modified equation of 23.286 by omitting kV value, right? Then you go for compared, effective force should be less than bending force, or bending force is greater than effective force. Here consider this one, this condition better. Effective force is less than bending force. Then design also safe. Whatever the module we choose, that is safe. Design is safe. Now that completes what? Second step. Right? First step, identify weaker member. Second step, design against static load. In the design against static load, one is tangential tooth load from power transmission. Second one, tangential tooth load from Levy's equation. We compare those two equations by trial and error method. We get the normal module. Then third step, you go for check for the stresses. What are the individual stress should be less than allowable stress, and effective force is less than bending force. Then design is satisfactory. If the condition is satisfied, now the design is satisfactory. Next, third step, go for determine the dimensions of both pinion and gear tooth profile, also gear tooth dimensions by referring the table number 23.1. By referring the table 23.1, right? Then apart from that, also calculate center distance and other things, and are also refer the equation from 23.241 to 250, some other dimensions. Next, that completes third step. Now fourth step, again go for design against dynamic load. For design against dynamic load, you go for refer the equation number 23.309a. 23.309a. Again, what is the terminologies here? The cos beta will come to the picture here. There is a one more additional term in that what we use the formula for design of spark. Same formula, but first cos beta will come to the picture. Again, Ft is a tangential tooth load that we determine from the 23.87b. Vm is the mean pitch line velocity. B is the phase width. C is what? It is a dynamic load factor, right? Correction factor. Dynamic load factor or coefficient. You know how to calculate dynamic load factor or coefficient by referring table number 23.32. It depends upon the material, pressure angle, and error in action. Material also we know that, pressure angle also we know that. What is error in action? Error in action can be determined two ways. One is the type of gear cut. Is a precision gear, class 1, class 2, or class 3 gears cut. Or else by based on the mean pitch line velocity. If you know the class of cut, the precision or carefully cut gear, then you go for refer equation number 23.34 to calculate error. Or if you based on mean piston velocity, you go for by using figure number 23.35a, you go for calculate error in action. Then by referring 23.32 table, you go for calculate the dynamic load factor or coefficient. Then already beta we know that the given in the problem, the helix angle, then substitute will get the dynamic load. Once you calculate dynamic load, then that after that last step is design against a wear load. Last step here, design against wear load. Again, from the design data handbook, the equation number 23.310, the wear load T1 BQK all divided by cos square beta, that should be greater than or equal to FD value. What is D1? It is the physical diameter of pinion. B is the face width. B is the face width. Q is what? Ratio factor, that is 2 times of ZB2 by ZB1 plus ZB2. There is a virtual, either consider virtual teeth or actual teeth. 2 times of Z2 by Z1 plus Z2. What is a K? It's a load stress factor. If I know the hardness number, then we go for determine the K value, right? By referring equation number 23.32. If you don't know the hardness number, now we'll go for determine K value. The K should be greater than or equal to the conditions. Then by referring the table 23.37b, we'll go for determine the BHN for pinion and gear. Or if the value BHN value for pinion and gear is given, then we'll go for determine the load stress factor. right? That depends upon the hardness number. Sigma Fc depend upon the hardness number. Then E naught stands for equivalent and smallest. Then how do you check whether design is safe or unsafe? The design should whatever that the wear load should be greater than the dynamic load, greater than equal to dynamic load. And one more force is there, that is what it called as endurance strength. Okay, that endurance strength F minus that all should be greater than wear load should be greater than dynamic load. Now usually not go for endurance strength unless until if you ask the uh, the problem, otherwise you don't go for the endurance strength. Just only see this condition, wear load should be greater than or equal to dynamic load, therefore the safer design, right? Next, what are the assumptions you should made? Now these are the 5 steps. One is identify weaker member, design against static load, design against, so then you go for take the dimensions, design against dynamic load, and fifth one is design against wear load, right? After this, what are the assumptions you should make? Some of the in the problem, some data are not given, insufficient data are there. Then what are the assumptions you should make? Yes, the slide is visible, please check.
Yes, sir. Visible, sir.
Okay, ma'am. Now what are the assumptions you should make? The first assumption is if the pressure angle is not given. If the pressure angle is not given, then what we should go for? Assume here pressure angle to form is not given, then you should assume 20-degree full depth involute. Next, the type of service is not given, service factor is not given, then you go for assume medium shock 8 to 10 hours duty per day. Suppose in the problem helix angle is not given, then you go for assume helix angle should be 23 degree. 23 degree, the angle between the tooth and the axis of rotation of the shaft. Next, if the material of the both the pinion gear is not given, then you go for assume the pinion is made up of 0.40 to 0.50% of carbon steel and untreated one. Then you go for determine for gear material. Then the wear and lubrication factor is not given, then you go for take a scant lubrication but regular inspection. Suppose if the number of teeth is not given, then you go for assume the minimum number of teeth on the pinion to avoid interference for 20-degree full depth involute by referring table 23.6. Now what is the Z1 we should take? Either 18 teeth you take or else 20 teeth you take. Now what do you mean by interference? Minimum number of teeth on the pinion to avoid interference, that you have discussed in your kinematics of machine, right? Is anyone unmute yourself? Those who know the answer, please unmute and tell me what do you mean by interference. Interference. Yes, 76 members of participants are there. Is what do you mean by interference? Interference. We have solved so many problems on that to avoid the interference. What will be the minimum number of teeth, right? So interference is nothing but when you two gears are meshed to each other. When two gears are meshed to each other, what happens? There will be a slightly one gear tooth is slightly wear over the another one. There will be shock load, impact load occur over that. In order to avoid means that clearly they will be meshed each other. Otherwise, if you not mesh each other properly means what happened? The shock load or the sudden load will occur here, and there may be gear tooth will be failure takes place. The gear tooth will be wear more and will maybe break suddenly. In order to avoid that, we'll go for avoid that interference. How many teeth are should be there? For 20-degree full depth involute system, minimum we should take either 18 teeth or 20 teeth. Next, fourth assumption, the phase width we should consider is 10 times of normal module. Once you determine the normal module, then once you determine the phase width, you should check the phase width should be greater than the minimum value. What is the minimum value? Is 5 times of mn by sine beta. Next, one last assumption here for double helical gears, and please read the problems. The single helical gear, usually they will give single helical gear, means only one gear. It may be left hand helical or right hand helical gear, right? The single helical gear they will give. Suppose if double helical gears is given, both left hand and right hand helical gears that is formed on the single blank, single raw material, then please check the what will be the phase width should be. You consider is that B should be greater than B minimum, less than B maximum. And what will be the B value you should consider here? Earlier we'll consider for single helical gear 10 times of normal module, but here we consider here for double helical gear it is B is equal to 35 times of normal module. Why it is 35 times of normal module means for double helical gear both the left hand helical, right hand. Okay, so I lost the signal. That's why it has disconnected. Now please check. I'm audible and PPT is visible.
Yeah, sir.
Yeah, in
Yes,
double
sir.
helical care. Yeah, thank you. In double helical care, you can see the both left hand helical and right hand helical, and in between those two there is a gap that will form on the single raw material, single blank. See, for single helical gear, it is how much? For single helical gear, it is 10 times of normal module. For double, it is at least twice, 20 times of normal module. But there will be gap between the left hand helical gear and right hand helical gear. That's why always you take for double helical gear, the phase width should be 35 times of normal module. Once you calculate here, please check it should be satisfy this condition. Right? If you not satisfy this condition, then take instead of 35 normal module, take 40 times of normal module or 45 times of normal module. Now these are the 8 assumptions. You should follow this. Yes. Yeah. These are the design procedure of helical gears. I will share these procedure, these steps. Please go through it. Okay. If you're familiar with this procedure, now we'll go for solve that problem. Or else today itself we'll go for solve the problem. Let's give me response. Does anyone give me response? Or else I'll go solve the problem. Yeah, today we discussed about first one helical gas. What do you mean by helical gas and what are the difference between Spurger and helical gas and types of helical gas and what are the advantages of helical gas compared to Spurger and what are the terminologies used. Very important terminology. Yes, I'm audible.
Yes, sir. Audible, sir.
Yeah, very important terminology is helix angle, that is beta, right? Yeah, next, what are the forces acting on the helical gas? There are three forces. One is transfer tangential to load, second one is radial force, third one is axial force. And these are the terminologies which are used and nomenclature or terms which are used in the design procedure of helical gas. Next, the 5 steps. Still we have 30 minutes time. Yes, please take that question. Is design. Yes, are you comfortable? Shall we go for solve the problem or you need for time to know the design procedure?
Sir,
Yes,
we will learn design procedure today. We will continue tomorrow onwards.
tomorrow. Okay, maybe
Yes,
the
sir.
yeah A section as usual. I will continue the class tomorrow. For B section, so Professor Ravi Kumar sir, Ravi Kumar M will continue the class. Okay,
Okay, sir.
okay, okay. Ma, wait for another 2 minutes. I will take the attendance. Yes, Chaitanyam, US number 404 is there on the line?
Yes, sir.
Okay, 1 minute. Ma, I will show you the how many classes you are attended. Mm, So wait a minute. Another Excel sheet is visible. Chetan,
Yes, sir. Visible, sir.
visible. Okay, 1 minute. Yeah. So Chetan, 19 batch 404. See this. This is the red color shows your absent. P stands for present. So only the on the 14th you are present, and yesterday class you are present. Yes. And one thing you do, not only you, for other people also, those who joined for first session or second session, please take the screenshot of the session. And if you are absent for any one session, means please send to the snapshot to my WhatsApp group. Okay. Yes, Chetan is visible.
Yeah. Visible, sir.
Okay, ma. Any clarification you want?
No, sir.
Okay, ma. Yes. Any other doubts? Anybody have the doubts for regarding that attendance? Please unmute
Sir,
yourself.
what about parallel batch, sir?
US number. Yes, please
Sir,
repeat.
parallel batch. Show me the
Yeah,
number.
parallel batch. Yeah. And now is visible. Parallel batch.
Parallel batch.
Yeah. Please check here.
Yes, sir.
US number.
432, sir.
Yeah, 432. Vijay Kumar CN. You are all present, ma. All session you are present. Right? Okay.
Yes, sir.
Yeah. If anybody have doubts,
Sir,
please.
until today, how many?
So total today's session, if we consider 16 session over, the today's session I will not take in attendance. Okay. Yeah. So give to another 2 minutes time. I will take the attendance. Yeah. So not only in my subject, if you are log in one session or two session, please take the snap copy of the session and please intimate to the subject teachers. And what about your internals? For A section students, if you're not done the topic means you're almost all 80 to 90% students are attended the spring chapters, right? But I didn't start that single topic in the spring chapter. So many students are attended two questions in the spring chapter. So if you read your own and if you write means good. But simply copying from the textbook means it's not good. You want to see the marks? Does anybody want to see the marks? Yeah,
Yes, sir.
yeah,
Yes, sir.
okay. Yeah, now it's visible. The Excel sheet is visible.
Sir, it is good.
Yeah, so first is a total 50 marks, then you round off into 30 marks by multiplying 0.6. Take anyone, you can see this. First, the nth column shows out of 50, the O column shows out of 30 marks it is. Yes, please see that US number from 17 batch 47 to 18 batch 22. Yes, if you have doubts, please unmute yourself and ask me that. Look, at 4 o'clock, some of the students have a meeting with HOD sir, right? That is a mini
Yes, sir.
project.
Yeah, sir.
Yeah, wait. I'll take another 1 or 2 minutes. Just will see your marks. Then I will end up this meeting.
Scroll, sir.
Yeah. Over from 17 batch 47 to 18 batch 22. No doubts.
Yes, sir.
Okay. Now see that from 18 batch 22 to 18 batch 45. Is Dhanush is absent? Is any doubt regarding 18 batch 22 to 18 batch 45 for your internal mass? Shall I scroll it?
Yes, sir.
Okay. Now from 18 batch 45 to 19 batch 404. Is any doubt? Any clarifications there?
Scroll it, sir.
Yeah. From 19 batch, the 19 batch 404, 405, right? Yeah. See at the same time, see the parallel batch also. This is visible. These are your marks for DME 2 test 1 for A section students, right?
Yes, sir.
Okay. Now, any clarification, any doubts are there? Please unmute yourself. If no doubts, then I will end up this meeting. Yes, shall I end this meeting?
Yes, sir.
Okay, thank you one and all for attending this meeting. Okay, I will send the design procedure of the helical case. Please go through those design procedure. Then tomorrow we'll go solve the problems of design of helical case. Thank you one and all for attending this meeting.
Thank you, sir.
Okay.